Hey friends, so here is a quick overview of inscribed angles, okay? Remember, inscribed angles have a vertex on the circle and it connects two chords. A chord is like these green lines, they're segments that connect the inside of our circle. All right, so keep that in mind. They form a big old V on top of our diagram. All right, the inscribed angle theorem says that the measure of the inscribed angle is half the measure of the intercepted arc. Okay? So, if our arc measure is x, we're going to take x divided by 2 to find our angle measure. Conversely, if we're asked for our arc measure and we're given an angle, we would multiply our angle by 2. All right? So, if I give you this example here, let's say that my arc measure is 96 degrees. To find my angle measure, I'm going to take 96 divided by 2. All right, so I'm going to plug that in my calculator, 96 divided by 2. And that means my angle measure is 48 degrees. If I give you this type of problem, where let's say my angle measure is, I don't know, let's say 53 degrees, then to find my arc measure, I'm going to take 2, multiply it by 53, and that gives me 2 times 53, I'm working it out myself, equals an arc measure of 106 degrees. Here's the second part to our inscribed angle theorem. It says, if two inscribed angles of a circle open up to the same arc, then the angles are congruent to each other. Their measures are the same, okay? So if I have this angle right here, A, that opens up to that pink arc, and then I have B, which also opens up to the pink arc, then the measure of angle A and B are the same, all right? Remember, that's what congruent means. So let's say that I say angle A, let me use a different color, is 34 degrees. Then by this theorem, by this part of our theorem, B is also going to be 34 degrees. Let's say I gave you an example that looked like this, and it says the intercepted arc measures 54 degrees, and I wanted you to find angle A. Well, all you have to do is divide that by 2, but it would be the same as angle B. So I can ask you for either angle. It doesn't matter. It's going to be the same answer. So 54 divided by 2 is going to be 27 degrees here and 27 degrees here. Here is another example for double inscribed angles. All right, I am asked for this arc measure right there. I look and I see that I do have an angle. I have this 42 degree angle, which is right here, but that is not the inscribed angle. This arc where my question mark is not the intercepted arc for this angle. However, if I zoom out on my diagram, I see that I have this diameter right here. And we know that with diameters comes semicircles. So XWV, arc XWV, forms a semicircle. And the measure of a semicircle is 180 degrees. So if I can find the measure of arc VW, I can subtract it from 180. I can do 180 minus the measure of arc VW. So that's what I'm going to do, because I can use this 42 degree angle to find arc VW. All right? So I'm going to erase some of this. And in order to find VW, all I have to do is multiply 42 by 2. And that gives me my arc measure. So in my calculator, 42 times 2 gives me an arc measure of 84 degrees. So all I have to do is 180 minus 84 to find my question mark. So 180 minus 84 in my calculator. This arc measure is 96 degrees. Okay, part 3 to our inscribed angle theorem says that any angle that is inscribed in a semicircle is a right angle. Okay, so if you look right here, A to C forms a diameter. That makes this little guy, the angle that's actually our inscribed angle, a right angle. Remember, the little box signifies a right angle, and a right angle has a measure of 90 degrees. So we're going to use that information to solve problems, maybe for angle C or for angle A, or maybe to find arc measures. Here is an example for part 3 of the inscribed angle theorem. My question here asks for the measure of angle D. Well, I can assume here that this line, D to C, is a diameter, okay? We're just going to go ahead and make that assumption here. Even though we don't really have a central point, I'm telling you it's a diameter, okay? That means that angle B is a right angle because diameters form semicircles, and our angle B is inscribed on a semicircle. So I know that angle B is a right angle. Remember, guys, the total measure of the inside of a triangle is 180 degrees. So if I want to find the measure of angle D up here, all I have to do is subtract 180 minus 68 minus 90. Or, if you're like me, I prefer to actually set up equations and solve for x. So you can do x plus 68 plus 90 equals 180. Does not matter. You will get the same answer in both situations. Okay, so I'm going to erase the second step just so I don't confuse you. And so in my calculator, 180 minus 68 minus 90 is indeed 22 degrees. All right, here is part 4 to the inscribed angle theorem, okay? It deals with inscribed quadrilaterals. And what is an inscribed quadrilateral? It is any four-sided figure whose vertices all lie on a circle, okay? So again, guys, vertices are just fancy words for points, whose points all lay on a circle. All right, so now that we know what the inscribed quadrilateral is, let's learn about the theorem. The theorem says that any quadrilateral, or if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay, and let me outline opposite angles. Guys, remember, this funny word, supplementary, means add up to 180 degrees. So you might remember straight angles. You might remember the inside of angle relationships, parallel lines, stuff like that. We use supplementary a lot. Means add up to 180. So B and D are angles that are directly across from each other. I like to draw straight lines between my angles that are across from each other. So B and D are supplementary. That means I can take angle B, add it to angle D, set it equal to 180, and their measures should combine to give me 180. Same for angle A and angle C, okay? A plus C should give me 180. If not, and they are across from each other, probably have done something wrong. Here is an example dealing with inscribed quadrilaterals and using that to find an angle measure, okay? We have to apply a bunch of different theorems here, or a bunch of different pieces of our theorems here, so stay with me, okay? In order to find x, I think that I need to do something with Z based on the information given on my diagram. Because if I look at angle Z, these are my two chords that meet at point Z. I have this intercepted arc right here, J, X, Y, that I'm given information about. So I'm going to combine 92 and 64 to find this whole arc measure right here, okay? So I'm going to add 62 plus, that is definitely 92 plus 64. And then I'm going to divide it by 2 to find my angle measure for Z, okay? So in my calculator, pardon me for a moment, 92 plus 64 gives me 156. 156 divided by 2 is equal to 78. So angle Z is 78 degrees, okay? Because I found this green intercepted arc, divided it by 2 to find my angle measure. That being said, I'm going to erase some of this so that's a little bit clearer. Now I can use part 4 of my inscribed angle theorem that says that opposite angles are supplementary, which means that X and Z are supplementary. They should add to give me 180. So X plus Z equals 180. I'm going to substitute the information that I have, aka angle Z. So X plus 78 equals 180. And from here, I'm just going to solve for X, and that'll give me my arc measure. So subtract 78 from both sides. That cancels. On the other side of the equal sign, it balances. And X is equal to 180 minus 78, which is 102 degrees. So X is 102 degrees. Okay, I hope this helps.